Hello, this is John from Tablet Class Math, and in this particular video we're going to look at the basic steam cycle on board ships. So you first might be wondering, well, why is this math guy talking about steam cycles on board ships? So good question. Well, in a former life I actually was a U.S. Navy officer and engineer on one of these ships. And it really gave me a chance to use my math degree and that kind of analytical skills I developed in mathematics in the engineering field. So that carried me forward. When I left the service, I actually went into chemical engineering. So it's a really enjoyable topic. I just like engineering. I like mathematics. So, chances are if you're interested in math, you like engineering. And of course, if you're an engineer, you likely enjoy math. But the goal of this video is to give anybody who's interested a real basic appreciation of the systems involved to actually propel a ship like this, for example, through the water. And that's pretty amazing when you think about it. So anyways, we'll talk about that more in a second. But first of all, let's just talk about ships in general. Okay. And by the way, before we get going, what I'm going to talk about in terms of the engineering here applies much more than just shipboard technology. A lot of what we're talking about is how basic power plants run to produce electricity, in your local state or community as well. So hopefully if you got a few minutes, you're going to definitely learn something if you have no clue on how these things work. So I'm going to keep it simple, but just interesting enough where you'll walk away with some good knowledge. All right, so let's go ahead and start here. So let's take a look at this ship. This is a U.S. Navy amphibious ship. Now this particular ship is propelled by a steam plant. Okay, now not all ships run on steam, and I don't know what the particular breakdown is, but I probably venture to guess that all the ships out at sea, maybe like 50%. I could be totally wrong here, but I don't think I'm that far off. But maybe like say 50% are propelled by steam. So that leads us to the next question. Well, if they're not run off a steam plant, the ships don't go through the water via a steam plant, well, how else do they work? And I would say the breakdown, I'm just kind of making these numbers up per se, but let's just kind of do it this way, 25%, and this might be off as well, but I don't think these numbers are too dramatically off. But anyways, let's get to it. So I'd say maybe half the vessels out there are operating on steam. The other half is composed of diesel, diesel engines, just like a Big Mac truck running big, huge, and gigantic diesel engines. And then the other portion would be gas turbine, and that's basically like a jet engine. The things that make your 747s go, they pretty much take a couple of those engines right off you kind of think of the right off the wing of an airliner and stick them in a ship, and pretty much that is the main power plant source. So this is clearly an oversimplification for those of you out there that are directly in the field or are experts in this, because of your background. But for those of you who have no clue about this stuff, this will give you a pretty good idea. So that's pretty much it. And then I'm sure there's other power plant source. Of course, we have wind out there when we talk about sailboats. But anyways, these large, huge vessels, you're talking, maybe like 30,000 tons, moving through the water. That's a pretty massive feat, to be able to have the power to push something like this around and maybe say 20 knots, which is pretty good, and it's a little bit over 20 miles an hour. So let's go ahead and talk about this now. How does this work? So I'm going to focus just on the steam cycle, and here we go. So this is the steam cycle, and I'm going to walk you through it step by step. Okay, and just take a few minutes, but once we get done with this, I think you'll have a real appreciation of how a basic steam plant works. Okay, all right, so let's go ahead and start here with the boiler. All right, so just think of a pot of water on your stove, all right, or a boiler that produces heat for your house. Essentially what we're doing is taking water and we're heating it up. Okay, that's what we're doing. So this box here with the two round circles inside is going to represent our boiler. So all these other little lines and schematics, just kind of ignore all that for now. Now let's just focus on the boiler. So essentially, you can kind of think of it as a big pot of water that we're heating up, right? And we're going to produce what? Steam. Okay, steam is going to be our source of power. Now, for those of you who really want to get an appreciation of steam, uh, I'll tell you, I just can't stress this enough of how powerful steam is. Just go ahead and, well, I'm not recommending this, but I'm sure everybody probably has an experience of having some water or something else boiling on the stove with the cap, or the lid on top of the water. Let's kind of just go over here, right? So you have your little lid, and here your little fire's going away. Now steam's starting to come up, right? And you lift that lid up and steam comes out, and it's hot, and I mean it really wants to go. Steam is massively power. So you think about the kind of energy that's being produced with these boilers. And by the way, these boilers that we're talking about, we're talking like two-story, maybe even sometimes larger size boilers. Like here's a person in relationship to the size of the boiler. We're talking pretty big, massive boilers. So that's the kind of power that we need to produce to move, 20, 30,000 tons, through the water at 20 miles an hour plus. So anyways, so steam, big time powerful, and along with that, extremely dangerous. And I don't want to kind of go, take too many tangents here in this basic lesson, but it's real serious safety business when you're operating one of these plants. So for those of you out there who've been there, done that, and who've worked in power plants, especially steam plants, I'm sure you have all kinds of stories to tell about, when things go wrong, bad things happen for sure. So anyways, so that's steam, okay, and appreciation for it. But let's kind of get into the boiler here a bit. So you can see here, I'm representing the boiler by two circles, okay? And essentially, maritime boilers, and this is different types, but this is a kind of a common type. They just basically have water in two drums. Okay, this is actually called the water drum down here. And then these lines represent tubes that kind of go up from this big drum. Okay, and kind of think of me as being about this size, and this is, for you out there who've actually done this, like I said, this is totally off. This is really oversimplified, but just think of it, this is a big cylinder, big water drum, that's what it's called, and these water tubes that connect up here, and they're just tubes, and the water essentially fills up to another big drum, and this is called the steam drum, this drum here. Okay, so you have water, if you can think of it that you filled up water and it's kind of like floated down through here, fill this up. That's pretty much what we got. Now, this is kind of our setup of our boiler. Now, the orange and the red here represents, fire, heat, however you want to call it. And that's produced on board Navy ships. And I'm going to speak about the Navy, and I'm sure it's pretty much the same way. Now, they use a different combination of things. They use, like, say, jet fuel, DFM, diesel fuel marine. They can even use JP5, like I said, was like jet fuel. That's not so common. You're going to use some sort of marine fuel, and I don't want to go too much into the boiler, but essentially that fuel gets atomized. Okay, kind of think of it gets sprayed in to the boiler, and there's a heat source, and that fire just kind of gets going. I mean, think of it as a massive furnace that's producing, just intense heat. So that's pretty much how we fuel the fire for the boiler. So we're using some sort of diesel fuel marine type of thing. Now, back in the good old days, probably talking, I don't know, 40, 50 years ago, they would use oil, okay? And I think they used to call it black oil, and I'm sure some of you here that really know this stuff, please comment on a YouTube video. I'd love to get your feedback on your experiences. But they would use this other oil, black oil, for example, and you would really create a lot of soot, and you'd see these ships. Here, I'm kind of go to my ship here. They would be like just bellowing big, black smoke, and you see those older movies like the Titanic and stuff, you see just, tons of black smoke. That's the fuel they were using. And, as we've gotten more efficient, you just won't see that so much. All right, so here's our boiler. It's our heat source, right? We're spraying in some sort of diesel fuel marine. We're kind of atomizing it, kind of like spraying it like a spray can, and it's burning just nice and toasty here. We have our water, and now these tubes, okay, right here are getting hot, obviously, right? And it's creating steam, okay? So our steam is kind of like bubbling up through these tubes, and eventually it's going to escape up here in our steam drum. All right, so this is where we're going to kind of continue this process forward. So now that we got steam, here, I'll put it right here, steam, okay? This is very, very powerful steam at this stage of the game. And it's what we call saturated steam, okay, or wet steam, okay? So the steam is coming out, and it's all dependent on your boiler types, but you could be coming out of the boiler at, let's say, maybe 700 psi. Okay, and it could be a little bit off, but my memory serves you correct. This is pretty close to what it could be. That's just ridiculously powerful and dangerous stuff. So there's all kinds of safety devices on boilers, relief valves, etc. So we don't blow the boiler up and everybody anywhere near it as well. But this particular steam is not the steam that we're going to use in our engine yet, because it's saturated steam. In other words, if of course, when you feel steam, if you microwave some water and you put your hand over it, you feel steam coming up, but you also have that condensation, right, the wetness to it. So what we want to do is get all the water out of the steam, at least the best we can. And I'll tell you the reason why in a second. So anyways, we're going to take this steam, and we're going to here kind of follow my... let me see if I can use a different color. So we're going to take this steam, okay, it's out of the steam drum. Now what we're going to do is we're going to take that pipe, if you will, and we're going to pipe it back through the boiler again. Now, why do we do that? Well, we're kind of heating up the steam. And the reason we're doing that is to get any last little bit of water out of the way. Okay, we want to make this steam as waterless, if you will, because, and by the way, at this point of the game, once we have the steam that went through the boiler, and I'm going to talk about the water tubes here, I'm talking about the heat source. What we have is superheated steam, okay, and that's serious business there, okay. So now we have our superheated steam, which we would call, for lack of better terms, dry steam, okay, and now that is our punch. This is the power, right? So here, this super heated steam, this is huge power that we just created. And now we're going to do stuff with it. And that's the whole idea. So this is kind of the steam generator, if you will. And we generated this superheated steam. Now, what we're going to do, and now remember, I'm talking about a basic steam cycle on board ships, but this would be applicable to even a power plant out at sea. The whole idea, or excuse me, a power plant on land, the whole end game here is to turn a shaft. Now here's my shaft here, and that's my little representation of a propeller, pushing a ship through the ocean. But this shaft here could be turning a generator, and that's basically what happens on land when you're creating electricity. Okay, so that's the end game. Make something turn. Okay, our shaft is going to turn either a generator or turn a propeller or whatever you want it to turn. So how does this work? Well, now that we have our superheated steam, what we're going to first do is put it through a high pressure turbine. So you can see here I have turbines, and this represent our turbines. And turbines, you kind of think of this as a jet engine, essentially. Okay, that's what it is. It's a series of fan blades. Once again, total oversimplification, but close enough to what really happens to give you an idea. So here's like these fan blades. You got this superheated high pressure steam that's going to come through, and it's going to go into this chamber. Kind of just think of it almost like a jet engine, if you will, and it's going to turn that jet engine. It's going to spin it around, or turn the fan blades mechanism, and it's going to spin. Now what it's doing is spinning the shaft, and I'll talk about this in a second, and that's connected to this MRG. That's a transmission, if you will, but we'll hold that thought for a second. So once we've put this superheated steam, high pressure steam through this high pressure turbine. Now, the steam, has spun this thing, but it's kind of like, okay, think of, I'm kind of like talking like if I was steam for a second. I'm like, all right, well, I've turned you, so I'm a little less powerful. I'm a little less tired, or I'm tired, tireder, if you will. I lost a little power because I just got done turning these big fan blades. But it's still pretty seriously powerful, okay? So what we're going to do is we're going to continue to capture the steam energy. Okay, we still have a tremendous amount of energy to capture, and what we're going to use is this exhaust, if you will, off the high pressure turbines, and we're going to spin another set of blades. Okay, and this is our low pressure turbine. Okay, so we're going to be capturing 2 turbines, and a low pressure turbines shaft here is also connected to the main reduction gear. Now the main reduction gear is essentially the transmission, if you will. Okay, and I don't want to get too far into it because this video will take a long time, but it's just a bunch of gears, just like a transmission. You got a couple pinions here that are just turning, spinning this whole thing, and you're taking really super fast turning mechanisms. I put RPM here. These things, I don't even want to guess how fast they're turning, but they're turning extremely fast. And the whole idea is you got to take that and you got to reduce that speed down, step it down until you can turn a shaft, okay, and our propeller through the ocean. Trust me, a ship's propeller is definitely not turning 6,000 RPM. These big huge ships, they're probably going in, I don't know, maybe probably 150, 200, something like that. I could be off, but I think that's probably pretty much in terms, and it of course depends on what speed you want the ship to go, but you get the kind of idea. Let's say it's a couple hundred RPM. It's definitely not thousands of RPM a second. All right, so let's just kind of like stop here and quickly review. So we got our boiler, our steam generator, right? So we're taking this water, we're creating first saturated or wet steam. We're taking our steam, we're piping it back through our boiler to get all the water out. To make it superheated steam, we're going to pipe it through our turbines. Now, a little bit about the wet steam. Now, the reason why I said it's really critical that we get any moisture out is when the energy here that we're going to introduce into this high pressure turbine, okay, and both of these turbines, if by any chance you get a little water droplet here, let me just draw some water droplets like this, okay. At the power that we're talking about, these little tiny droplets can actually act as almost like grenades or like rocks that we would throw in, and it would knock off these fan blades. That's bad. Okay, they can actually damage the turbine and actually just ruin the whole thing and actually have an explosion, if you will, because these fan blades would just get destroyed. It's almost like maybe this is not the perfect analogy, but it's like when airplanes fly and they get what they call a bird strike. Like a bird will go through the engine, okay, and it will damage, actually shut the engine down. Kind of the same idea with the saturation. You go in there and you're really risking, messing everything up and causing a dangerous situation. So that's why we really need the superheated dry steam. All right, so here at this point of the game, we have our steam and went through high pressure turbines. We're capturing the exhaust of that through low pressure turbines. We're reducing the speed of those turbines down through a transmission, if you will, called the main reduction gears. And then we're turning our shaft to spin a propeller in the water. All right, so this is kind of like the first half of the game. Okay, now what we are going to talk about is the second half. And remember, this is called the basic steam cycle, which means we're going to kind of have a closed loop system here. So once we're done with the low pressure turbine, our steam is pretty tired at that point. We're saying, okay, you got me turning these turbines, and all the energy for the most part is expelled. We used it up in our turbines and our reduction gears, etc. But what we want to do is take that steam, okay, at this point, this tired steam, and turn it back into water and repeat the cycle. So let's talk about that. So this steam is going to, when it comes out of the low pressure turbine, we're going to put it into another big vessel. Okay, these are kind of like cylinders, tanks, if you will, and this is called the condenser. And it's basically, like condensing it. Let's say you take your steam, right, and put a cold mirror over it, and you'll see water form, right? Because it's condensing. We're just taking the steam, cooling it down back into water. So remember, we're still talking about H2O. Okay, if we heat it up, we get steam. If we cool it down, we get water, right? So this is basically what we're going to do. We're going to cool this steam down to get water, and the technical term for this water is called condensate. And now, so this represents condensate, and I'll talk a little bit about how we cool this down. But one of the things that you might be asking is, well, why do we care about capturing this water again? Why don't we just have like an endless water source to fill up this steam drum? Why don't we just pipe in a not a water hose, but maybe just take some water from the ocean and stick it in there? And why do we really care about capturing the water and using it again? Well, great question if you were thinking that. And the reason is this water, okay, that we use for our steam process is, very, specifically, it's chemically treated water. You just can't use regular water because you can really, really, really damage the boiler. Okay, let's suppose I used let's say seawater, if you will, or any old just run-of-the-mill untreated water, if you will, in the steam drum process. What's going to happen is, because you're creating steam, you're going to go through what they call oxidation. You're going to rust. You're going to rust out this boiler in a matter of hours. And actually, that's happened where engineers, for one reason or another, got lost their way on what the water specifications for what was going on in the boiler, and you can have oxidation going on, and you can rust out tubes. Okay, rusting can occur, and we all know what happens when you think about aluminum or steel. When it rusts, okay, it gets weak, and then eventually you have holes. And believe me, the last place you want to have any little pinholes or rusting or weaknesses is around something with 700 psi of steam. Okay, so very, very dangerous. So we have to be extremely cautious on having water such that it's treated to reduce rusting. Okay, and once again, this is an oversimplification, but I think it captures the gist from an engineering standpoint. Okay, so that's why we want to recapture this water. Remember, we're using chemicals, it's treated, so we don't want to just like continue that on. That would be very expensive and really inefficient. So that's why we have the steam cycle. All right, so here's our condenser, and we're going to take the steam, we're going to cool it down back into condensate. Now, how do we do that? Now here, essentially, we have this big series of pipes that run through this vessel. Okay, this vessel we call condenser, and it's basically just a big tank that fills up, takes steam and fills up with water. And here we can use seawater, okay, because it's not going to touch the steam. All it's going to be touching is the cold pipe. Okay, so think of it as a pipe that we run seawater through, and so here you got just seawater. We dump it back out at sea, but it's nice cold pipe. So when that steam hits it, it turns into condensate. So that's kind of the condensation. So now we're for steam. Now we're back to condensate. We're back to water, kind of the pre-phase before it goes to the boiler. So this condensate gets pumped. This is just a condensate pump here. It's a little CP. So we're going to pump this condensate. And notice I'm calling it condensate, not water. And we're going to pipe it over to here to the DFT. Now the DFT is called the deaerating feed tank. So what's the deal with this? Well, this is kind of like our feed water, all right, that we're going to feed the boiler. Okay, we're going to come back up here and start the process again. And this is where the water gets, tweaked, if you will. We're really testing to make sure that the water before we send to the boiler is appropriate. But the deaerating part it's a reference to taking the air out of it, okay? And that's one of the main reasons for the rusting, okay? So the deaerating is kind of like taking the oxygen, any oxygen that we picked up during this process out. And I'm not going to get into it too much, but essentially what happens is this condensate gets splashes in this tank here. We just push it through with splashes, and we are essentially taking water and smashing it against the tank, trying to knock out oxygen molecules, and then we kind of have a pure form of the condensate down here. And then what we do, we're kind of treating it with chemicals, getting this water, this feed water, just right. And then here we have our main feed pump. Okay, these are big, huge pumps, by the way, that come up and take this water and fill our steam drum, or excuse me, our steam drum. Okay, this is our water that kind of like floats down into our water drum, and the process repeats. So, and this is a extremely efficient process. Now you're losing a little bit of water completely. You're not capturing all the steam 100% back into condensate and back into water and doing it. You're losing a little bit, so you do have to kind of make up, add a little bit of water, over time. But this is the basic steam cycle. Now I was talking about this in terms of being out at sea or maritime situation, but this is pretty much it. Also on shore, okay, like a power plant. This is pretty much it. So in review, we had steam, okay, a steam generator. We had our turbines, right? And the turbines turned the main reduction gear, which turned our shaft. Then we used the exhaust of that steam. We finally, used all its energy. We converted it back into water or condensate through the condenser. And then we treated that water. We deaerated it in a DFT and then treated it along the way and put it back in our boiler. So anyways, so that's pretty much it. I can kind of go on and on and on. I'll probably end up starting to tell you tons of Navy Sea stories about what can go wrong. And these plants are very interesting to run. I'll tell you something. It's I really have an appreciation of it, and that's why I made the video. So I certainly know those of you out there who've worked in the field, who've especially been out at sea, will get a kick out of this video. But those of you that were just interested, you definitely learned probably more than you'll ever need to know about the basic steam cycle. Anyways, listen, I'm going to go ahead and leave you with this. My passion now is mathematics, and has been some time. So if you're interested in learning some mathematics with me, you want to come over to my site, tabletclass.com. Okay, and here myself and our team, we offer some awesome online video math courses. So please check us out if that's something that you're interested in. And thanks for watching the video. By the way, please subscribe to my YouTube channel, as I'm always doing some non-mathematic videos. So if you like this, I'm sure I'll probably do something in the future that you might like as well. All right, have a great day.